Hi, I'm Lance Gabriel, and along with my friend Chris Jane, we'll be explaining what projectile motion is.
Projectile motion is a type of motion that describes the movement of an object or projectile moving in a curved path through the air due to an initial upwards acceleration and the force of gravity pulling the object down. This curved path is commonly expressed as a parabolic curve that can be viewed in things such as balls getting thrown through the air. Additionally, projectile motion can describe things falling forward with an initial forward acceleration but without an upwards acceleration, forming what would be the climax of a parabola and its fall. This can be viewed in things such as a ball rolling off a table. It should be noted that projectile motion always has an object in free fall located in a two-dimensional plane.
An example of projectile motion can be seen in this video of me shooting at Colt 45. In this case, a firing pin hits the primer of the bullet, which ignites the gunpowder and forces the bullet forward with a force of around 712 joules, propelling forward at about 595 meters per second. A fundamental law of projectile motion is that the x and y components are independent of one another, with the y component affected only by gravity and the x component affected by the velocity of the bullet and the angle fired. The Mythbusters showed this perfectly in their experiment to find whether or not a bullet fired or a bullet dropped and on the ground at the same time if dropped from the same height. And judging from the video, they do. This goes to show that projectiles' components are independent of one another.
39.6 milliseconds. That's how close those two bullets were.
The projectile motion equations as shown can be used to determine horizontal distance, where x is equal to the velocity of x multiplied by time, horizontal velocity, where velocity of x is equal to the velocity of x initial, vertical distance, where y is equal to velocity of y initial multiplied by time subtracted by 1/2 gravity multiplied by time squared, and vertical velocity, where the velocity of y is equal to the velocity of y initial subtracted by gravity multiplied by time. So here's some examples of projectile motion in the real world. A car driving off of a cliff will display the effects of an initial forward acceleration as well as the downwards acceleration of gravity as it falls.
Two people playing catch will display projectile motion as the ball will move in an arc with the upwards acceleration from point theta being cancelled by the force of gravity's downward acceleration.
Now let's try to do a problem together. John Stamos, who's currently twice as fast as Usain Bolt, is running 20 meters a second in the x direction off of a cliff. Let's try to find the height of the cliff, h, the distance he jumped off of the cliff, x, and his velocity in the y direction, which is represented by v sub y. We're given his time, which is 5 seconds, and again, his initial velocity in the x direction, which is 20 meters a second. Now we'll solve for the height of the cliff. We'll need to use the equation for vertical distance. We can cancel out the first part, where velocity of y initial times time is negligible because we're starting on the ground. We can also cancel out the negative because gravity is negative, so the two negatives would cancel out anyways. We next solve 1/2 gravity times time squared, which is 1/2 multiplied by 9.81 multiplied by 5 squared. We then get the height of the cliff, which is 123 meters. Next we'll solve for how far John Stamos traveled after jumping off of the cliff. We'll use the equation x equals velocity of x multiplied by time. We can plug in the numbers that we are given and have 20 meters a second multiplied by 5 seconds. This gives us the final answer of 100 meters for how long he traveled. Finally, let's solve for John's velocity in the y direction. We'll use the equation Velocity of y initial minus gravity multiplied by time equals velocity of y. Next, we plug in 0 for the velocity of y initial, subtracted by 9.81, multiplied by 5 seconds. This gives us the final product of negative 49.05 meters a second in the y direction.